Okay, here are some homework problems from 16.8, number 2. 0 to pi over 2, 0 to 2, 0 to 9 minus r squared. This is in cylindrical coordinates. So this tells us that theta is between pi over 2 and 0. R is between 2 and 0. And z is between 9 minus r squared and 0, which is 9 minus x squared minus y squared. So if we draw that, we have this parabola shape in the x and the y plane. So we have this parabola, and this is 3, and this is 3. But r just goes from 0 to 2, so we're going to cut it at 2. And so this is going to be cut right here. And it's going to kind of look like that. And theta is from 0 to 2. So it's just going to be that first quadrant in the xy plane, because theta is 0 here, and this is pi over 2. So theta is going to go from 0 to pi over 2. Here's r. R is traveling from 0 to 2. So it's going to be all that. Quarter circle. And then it's bounded by the parabola. So we're cutting it out of the paraboloid. Okay, let's see what it asks us to do. Sketch the solid whose volume is given by the integral and evaluate the integral. Okay, so I'll go ahead and evaluate this one. It's going to be with respect to z first, so we get rz 0 to 9 minus r squared is 9r minus r cubed. Then I'm going to integrate with respect to r, so that's going to be 9r squared over 2 minus r to the 4th over 4, 0 to 2. It's going to be 18 minus 4, which is 14. Then I'm integrating 14 d theta, so it's 14 theta from 0 to pi over 2. So I get 7 pi over 2. And number 4, same thing, I'm supposed to sketch that region. And it does represent a volume because in both cases, in the first case, the function was 1, and in this case, the function is 1. So it does represent a volume. So rho is between 2 and 1. So that's like a radius. Z is between pi over 2 and pi and pi over 2. And theta is between 2 pi and 0. So when we draw this, rho is between 0 and 2. So here's between 1 and 2. And phi is between pi and pi over 2. So phi's out of out of this. So here phi is 0 and phi is pi. So on this line, phi is pi over 2. So it's going to be underneath here. So we're going to have it's probably like a sphere, a half sphere. With a hole in the middle. It's going to be underneath the xy plane because phi's measured from here. Here's phi 0. And then pi over 2 to pi is going to be underneath there. And theta goes all the way around. So we get the whole thing. Get the whole circle. So it's a sphere with a little sphere taken out of the center. Okay, I'll let you integrate that. Number 8. Okay, E is a solid in the first octant beneath z equal 1 minus x squared minus y squared. So that's 1 minus r squared basically. So it's beneath this paraboloid. Okay. If we do cylindrical, we need the r, d, z, d, r, d theta. So we need that extra r. Then z is between 0 and 1 minus r squared. Let's do the z first. Then the y is between, or the r is between 0 and 1, because this is 1 and 1. So 0 and 1 is r. And then theta, it's just in the first octant, so theta goes from 0 to pi over 2. And in there, the function is x cubed plus xy squared, but x is our cosine and y is our sine. So that's what's going to go in there. And then I've changed it to cylindrical coordinates. Okay, let's go ahead and do this one. If I multiply that by r, okay, I'm integrating that with respect to z. So that's just going to be that times z from 0 to 1 minus r squared. Well, that's going to be that times 1 minus r squared, so it's going to be r to the 4th cosine cube. And then when z is 0, it's 0. Okay, then I integrate that with respect to r. Zero to 1. Okay, that's going to be 1/5 minus 1/7. That's going to be 2/35 cosine cube plus 2/24 is 1/12. Then I'm going to integrate that with respect to theta. Now I'm going to use the table here. Cosine cubed, okay, that's 1/3 times 2 plus cosine theta squared sine theta. Okay, plus 1/12. If I let u be sine, and du is cosine theta. I'm talking about this part. So I'm really integrating u squared. So that's going to be sine cubed theta over 3. And then that's from 0 to pi over 2. So if I plug in pi over 2, that's going to be 4 over 105. Because the sine of pi over 2 is 1. And so that's going to be 0, and that's going to be 1. Plus sine of 1 over 36. And then if I plug in 0, sine of 0 is 0 and 0. Okay, so let me get my calculator. Okay, now I'm going to check that. And you could use Maple to check, actually, but this is number 8. Okay, I messed up somewhere. All right, I messed up way back here. Let me go and change that back to blue. This is going to be r cubed because I have an r squared here and an r here, so that's going to be r cubed. So when I multiply it by r, again, that's going to be r to the 4th. Then I'm going to multiply a cosine out of it. Let's factor out r out of here. Factor out r to the 4th cosine. I have cosine squared theta plus sine squared theta, which is 1. Okay, so when I go back and integrate, I don't need all this. All right, so I'm integrating r to the 4th cosine theta z, and that goes there, so it's going to be r to the 4th cosine theta minus r to the 6th cosine theta. Then I'm going to integrate with respect to r, so that's going to be r to the 5th over 5 cosine theta minus r to the 7th over 7 cosine theta, 0 to 1. Okay, then I'm going to integrate that with respect to theta. So that's just going to be 2/35 integral cosine is sine 0 to pi over 2, and that just gives me 2 over 35. Okay, so that was a lot simpler than what I was doing. Okay, number 12, we're doing a volume. So that means our function is 1. And we have x squared plus y squared equal 1. And we have x squared plus y squared plus z squared equals 4. So that says that r squared equals 1. Okay, so what we have here is a sphere, radius 2, and then we're cutting out a cylinder because in the xy plane, this is going to be x squared plus y squared equal 1, and z can be anything. So We want the volume of that in the first octant. Okay, let me read the problem. Okay, 14. Find the volume of solid, 12, sorry. Find the volume of solid that lies within both the cylinder and the sphere. So let's just do the first octant and then multiply by 8 because there's 8 octants. So it's going to be 8 times 1 r dz dr d theta. Now z goes from 0 to the square root of 4 minus r squared, because that's what this is. In the first octant it's positive, so I don't need plus or minus. And let's see, r goes from 0 to 1. So r, okay, that's what we want is this. The top of the little piece of cylinder and all this. And then this, and then this top of it. So it's going to look like this with the top on it. Let's see. It's going to look like something like that. Okay, let's look at our picture. All right, so r is going to go from 0 to 1, because we have x squared plus y squared equal 1. So r is less than or equal to 1, and 0 because we're in the first octant. And then we have theta, and theta goes from 0 to pi over 2 because we're in the first octant. All right. So when we integrate that with respect to z, we get zr and then u, so we have a minus a half out in front. I'm going to change my limits of integration, so instead of going from 0 to that, or 0 to 1, I'm going to go from 4 to 3. Okay, if you plug the 4 in first, I can get rid of that negative sign. All right, then I'm going to integrate that with respect to theta, and I keep forgetting my 8. And that's going to be that's going to be that. So the integrals aren't that difficult to do. Okay, 18. In 18, I have to use spherical. So let's change everything. X squared is going to be rho squared sine squared phi cosine squared. Y squared is going to be rho squared sine squared phi sine squared. And then I have this times phi rho squared sine phi d rho d theta d phi. Well, cosine squared plus sine squared is 1, so this is just the integral of rho to the 4 sine q phi. And I want to go H is the hemisphere that lies above the xy plane and below the sphere. X squared plus y squared plus z squared equal 1. Okay, so the radius of that is 1. So rho is going to go from 0 to 1. It's in the x above the xy plane, so phi is going from 0 to pi over 2. And theta should go all the way around. So theta goes all the way around, so that's 0 to 2 pi. And then I'll let you do the integration on that. Okay, let's look at 34. Okay, change to cylindrical. So since r squared is x squared plus y squared, this is going to go from x squared, r squared to r. X is r cosine and y is r sine, so it's r squared cosine theta sine theta z dz dr d theta. And I need another r. Okay, r, since we have, let's see, x is between square root of 1 minus y squared and 0. So x squared, let's just say equals. So that's a circle. So r is between 1 and 0. Okay, because x is between 0, x is positive, so 0 to 1. And then theta is going to go from 0 to pi over 2. Because y is between 0 and 1. So for y to be between 0 and 1, and x is inside, x is positive, we're just getting that part. This says that x is positive right here. So we get just the quarter circle. So we have to go 0 to pi over 2, 0 to 1 is our radius. Okay, in 36, Okay, y is between 3 and 0. I don't know if it's a circle, so I'll just do this. Okay, that's y. And x is between square root of 9 minus y squared and 0. So x is between 0 and the circle with radius 3. And x is positive, so I just get that quarter circle. And then here, this is r, and this is the square root of 18 minus r squared. Well, actually, I'm in spherical coordinates, so let's take this down here. I have z equal square root of 18 minus x squared minus y squared. Get everything on one side. X squared plus y squared plus z squared equal 18. So rho squared is 18. Rho is square root of 18. So rho, when I change it, is going to go from 0 to square root of 18. This right here, x squared plus y squared plus z squared is rho squared. Then I need another rho squared sine phi. Okay, d rho. And then d theta. Theta is between 0 and pi over 2 because I just get that quarter circle. And phi comes from here. I have x squared plus y squared is less than 9 squared. This right here is that's say less than or equal to 9, but that's less than or equal 18. So sine squared phi has to be less than or equal to 9/18, which is a half. So if you solve that, that's sine phi equal, let's say equal a half, square root. So phi is pi over 4. So that's how they get the limit down here. Let's do that in blue. We're going to go from phi, d phi is 0 to pi over 4. And that's what you have to integrate there. So you have to be careful when you're finding the limits of integration. Okay, I hope this helps you when you work on your problems.